In 1924, a doctoral student handed Paris a thesis so strange the committee nearly rejected it. They asked Einstein. Einstein called it brilliant. His name was Louis de Broglie, and his idea takes one sentence. If light waves act like particles, then particles should act like waves. Einstein had shown light carries momentum, waves behaving like particles. De Broglie simply reversed the arrow. Anything with momentum has a wavelength. The whole thesis is one line: wavelength equals h over momentum. The faster or heavier the thing, the shorter its wave. Lambda, the wavelength of matter itself. P, the momentum, mass times velocity. And h, Planck's constant again, the same tiny number from the last two films. An electron accelerated through 150 volts. Wavelength 1/10 of a nanometer. Exactly the spacing between atoms in a crystal. That coincidence made it testable. In New Jersey, Clinton Davison and Lester Germer were firing electrons at nickel, recording boring, featureless scatter. Then an accident contaminated their sample. Cleaning the nickel with heat turned it into a single crystal, orderly rows of atoms. The boring scatter vanished. Sharp peaks appeared at specific angles. Electrons at 54 volts should diffract like a wave of 0.167 nanometers. Run it through Bragg's law. The peak lands where observed. Exactly. Decades later in Japan, Akira Tanemura made it undeniable. He fired electrons through a splitter one at a time, never two in the machine at once. Each electron lands as a single dot. 10 dots, random. 200, faint clumps. 6,000, stripes forming. 70,000, perfect interference fringes. The electrons never touched each other. Each one's wave explored both paths at once and interfered with itself. The dot is where the wave collapsed. So why don't you diffract through a doorway? Compute it. 70 kilograms walking equals a wavelength of 10 to the minus 35 meters. That's 20 orders of magnitude smaller than a proton. Quantum mechanics doesn't switch off at human scale. Its stripes just get impossibly fine. The frontier keeps moving. 60 atom carbon balls diffracted in 1999. Molecules of 2,000 atoms by 2019. The wave nature never stops. We just stop seeing it. Who was this doctoral student? French aristocracy, a history degree, a Nobel Prize 5 years after the thesis they almost refused. A story of its own. Next, if every particle is a wave, what exactly is waving?